Hello everyone, welcome to today's lecture on interpolation. So first question is, why do we need interpolation? To answer this question, we discuss two practical situations where interpolation needed. First is, function is unknown and data is discrete. Suppose we have some discrete data of outside temperatures at different times that is recorded experimentally. At 8 a.m., temperature was 20 degrees Celsius. At 9 a.m., temperature was 20 degrees Celsius. At 10 a.m., temperature was 24 degrees Celsius. So in this case, actual function relating temperature and time is unknown, and we only have some discrete data values. Okay. Now someone asks, what was the temperature at 8:30 a.m. and how to find that temperature? So this question motivates us to know about interpolation. Now we discuss another situation. Suppose function is known, but it is complicated or expensive. For example, function fx is e raised to the power minus x square into sin x plus log 1 plus x raised to the power 4. So this function involves exponential terms, trigonometric term, and logarithmic term. So it is complicated, time consuming, and may be expensive for repeated calculations. So instead of using this function, can we find a simple function that behaves approximately like function fx? Here simple function means function that is easy to compute, give close results, and save computational time. So how to find that simple function that behaves like fx? This leads us to interpolation. So in both cases, either the function is unknown or it is known but complicated or expensive. We try to find a simple function that represents the given data or behaves like the original function. Now, what is interpolation? In case 1, when function is unknown and data is discrete, suppose we are given n plus 1 distinct points called nodes and corresponding values y0, y1 to yn. These values may be obtained from experiments or measurements or observations. We don't know the actual function that generates this data values of y for different values of nodes. Now our goal is to find a simple and convenient function px such that p of xi equal to yi for I equal to 0, 1 to n. These conditions are called interpolating conditions. That means the function px must pass exactly through all given data points. Means px naught equal to y naught, px1 equal to y1, and in similar way we can say pxn should be yn. Okay. Now this simple function is called interpolating function. Look at the graph. These are the n plus 1 distinct nodes. Red dots represent the corresponding values, and this green curve represents the interpolating function px. After getting px, we can find approximate value of px at any point between x0 and xn. Okay, so for example, suppose we want to find the value of px at x equal to k. So approximate value of p, it will be p of k. So interpolation is the process of finding a simple function that passes exactly through all given data points. Okay. Now, in case 2, when function is known, but it is complicated or expensive to compute. So again, we suppose these are the n plus 1 distinct points called nodes, and a complicated function which we denote by f of x. Complicated function means it may involve some exponential terms or trigonometric terms or logarithmic terms. Even here function is known, but we are not interested to proceed with this function because it may be time consuming, computationally expensive. So what is our goal? Our goal is to find a simple and convenient function px that approximates the function fx such that p of xi equal to f of xi for I equal to 0, 1, 2 and so on n. These are called interpolating conditions. Look at the graph. These are the n plus 1 distinct nodes and corresponding function values are fx naught, fx1, fxn. The blue curve represents the original complicated function and this green curve represents the function px, which is simpler function than fx. Note that at nodes, both functions fx and px have the same values. But between the nodes, px approximates fx. Means in between nodes you can see px is not equal to fx. But px approximates the function px. So finally we can say px is the approximation of original function fx. So we can say interpolation is the process of finding a simple function, simple and convenient function that approximates the given discrete data or function. Now an important question arises: what type of simple function we should choose as the interpolating function? In general, it could be linear function, it may be trigonometric function or exponential function or any polynomial. Okay, so all of these functions are possible for interpolating function. But in numerical analysis, the most commonly used function is polynomial. Why polynomial? Because polynomials are easy to differentiate, easy to integrate, flexible in shape, and suitable for most of the numerical problems. That's why we prefer polynomial functions. So polynomial interpolation is the process of finding a polynomial px that approximates the given discrete data or function. This polynomial px that we obtain is called interpolating polynomial. So friends, if you found this lecture helpful, please like the video, subscribe to the channel, share it with your friends, and if you have any doubt or question, write them in the comment section. Thank you very much.